So we have here a function, and it doesn't tell us what it is, but the question wants us to transform it somehow using what we've been talking about with graphing transformations in class. And if you remember, there are two main categories of graphing transformations that we've discussed so far. There's more coming, but so far what we've talked about is shifts and stretches. And sometimes stretches include compressions. Okay, it's just a different kind of stretch. So look at this graph. You should identify shifts as things that are, I'm not going to say plus or minus. I'm going to say addition or subtraction. Okay, so I see an addition or subtraction right there and right over here. So we have two of them. And one of them is horizontal, one of them is vertical. Now, if you remember, anything outside that parentheses, that function parentheses right here, anything outside this is going to be vertical. So I can see that there's a -4. That's a vertical shift. I'm just going to make a little list here. Vertical shift down 4. And what's that 1/3 over there? Remember, stretches and compressions, those are multiplication. Okay, when we're multiplying. So that 1/3, since it's less than 1, is a vertical compression. And we say it's a vertical compression of 1/3. We don't say it's a vertical compression of a factor of 3. Even though we know it's shrinking by a factor of 3, we call it a vertical compression of 1/3. So there's more going on here. We still have what's inside the parentheses, and anything inside the parentheses is horizontal. So horizontal, this looks like it's a subtraction, so that's going to be a shift. This is a horizontal shift. Now, which direction does this go in? Remember, horizontal is where everything gets kind of wacky. That is positive. This is negative. All right, it's kind of opposite what you would expect from the numbers on a number line. But what that means is this x minus 5 is actually a shift to the right by 5. Okay, so now I'm going to take all these ideas that I've written on the right side, and we're going to put that together on the graph. So I like this point right here as a starting point, except I'm just going to put it in black so we know it's part of the original parent function. Just so I can talk about where I want to start drawing. I'm going to select this button. If I were doing this in the homework, I would select the absolute value button, because that's what this parent function is. And I would start shifted right 5. But we're also shifting down by 4, so that's not going to be good right there. Let's go right 5, down 4. So I'm going to be starting my function here. And it's a vertical compression of 1/3. So if you think about what's going on here, see how this goes over 1, up 1? We're not going to be going over 1, up 1. We're going to be going over 3, up 1. So we're going to be going like this. Okay, that's going to have a slope that is 1/3 of the value of the original. So when we draw this, it's going to look like, I hope I can do this, something like this. Okay, there we go, that looks pretty good. All right, and that is how you graph a function based on this notation right here. We call this function notation up at the top. So we're asked a couple more things about this problem, domain and range. You should be a pro at domain and range by now, but you just look at the transformed function and say, what's the lowest x value? Well, that's -infinity, and the highest x value is +infinity. And the range, you see the lowest y value is -4, because it's been shifted down. And the highest y value is infinity.